geometric. Alright, so sequence and series is split into arithmetic and geometric, so we're going to jump straight into the exam papers because they are primarily geometric. Last week is important to cover. The reason it's important to cover is because they've been primarily geometric is don't be surprised if they throw in arithmetic this year. Is that alright? So, on the first page I told you to take down the formulas which are important for arithmetic and for geometric. So, last week the important ones that weren't in the logbook was the chain sequence was arithmetic, was Tn minus Tn minus 1, which gives a constant. It also tells us d above d, the common difference. And given Sn and looking for Tn was Tn is equal to Sn minus 1. So they were the two important ones that aren't in the logbook for arithmetic last week. This is geometric. So I'm going to the difference between arithmetic and geometric. What is the difference between the two? And arithmetic is? Exactly. It's literally as simple as that. Geometric multiplication, arithmetic is addition. So, what I mean by that is, for example, if you had a sequence 5, 7, 9, 11, that would be arithmetic. The reason the arithmetic is you're adding 2, 2, 2, and so on. A sequence, for example, that would be geometric, would be 3, 9, 3 for 3 is 9, 9 times 27 times 3 and times 3 times 3. So we're multiplying the number before. Alright? So that would be geometric. So geometric is to do with multiplication, arithmetic is to do with addition. The three formulas we get on geometric and logbook is trying to get Tn, how to get Sn, and how to get the sum to infinity, which has the following symbol. That is the symbol for the sum to infinity. That's the symbol for infinity. So a times 1 minus r power n over 1 minus r, and a over 1 minus r. Not in the logbook, two important things is calculating if it's geometric is t2 over t1 should be equal to t3 over t2. t2 stands for second term, t1 stands for first term, t3 is the third term, t2 is the second term, and calculating r. r is like the d in geometric. Formulas r stands for combination, i.e. multiplied by each line. Right. As I explained to you last week, this was literally redundant up until about 2016. When I say what I mean by redundant is it literally only come up about 10 marks. And then all of a sudden, 2018 paper 1, question 2 it came up. 2018 paper 1, question 5 it came up. 2018 paper 1, question 9 it came up. Literally, the whole of the 2018 paper, I think it came to something like nearly 100 marks. Out of the 300 mark paper. It was 1/3 of the entire paper 1 was literally sequence and series. 2017 paper 1 question 4, 2016 paper 1 question 9, 2015 paper 1 question 1, and literally didn't appear before 2015. So it literally has only come up in the last 3 or 4 years, and it's also, I think I added it to the bottom. Right, all the rest of the questions of the breeze, they came up last year as question 7 for 45 marks. Alright? So, as it came up, literally came up for 2015, maybe small, but 2018 was there 100 out of 300 marks, and 1/3 of your entire paper. Your overall grade is 1/6, 1/600 marks. Sorry, 100 over 600, which is 1/6. So literally, it has become incredibly important. Right, we'll start with the 2018 paper 1. Question 2. So, the first three terms of a geometric series are x squared, 5x minus 8, and x plus 8. Oh, just before we start, lads, just for next weekend, I have to get to a function. So we're starting at 9:30. That's okay. Alright? Apologies now to you who are late rise on Saturday morning. We have to kick off a half an hour earlier. I have to get to a function. Apologies. So, first three terms of the geometric series are x squared, 5x minus 8, and x plus 8. Where x is equal to r. Use the common ratio to show that x cubed minus 17x squared plus 80x minus 64. Anyone know how we'd attack the first bit? Find the, so This is geometric, so its difference is non-real ratio. So, use the first three terms of the geometric series to show that. We're using the common ratio, so i.e. that's the calculated common ratio. We're going to use it, so we're going to say T2 over T1 is equal to T3 over T2. We're going to use the fact that it tells us it's geometric, and we're going to see can we work towards that. So, x squared is our T1, 5x minus 8 is our T2, and x plus 8 is our T3. So off we go, using the T2 over T1 is equal to T3 over T2. Show me how you can get x cubed minus 17x squared plus 8x minus 64. One more minute, guys, at that. Right, so first three terms of a geometric series are x squared, 5x minus 8, and x plus 8. So we said that T3, T2 over T1 is equal to T3 over T2. So that is T2, 5x minus 8, over x squared is equal to T3, which is x plus 8, over T2, which is 5x minus 8. Ellen, what do you reckon we're going to do? Cross multiply, we are. 5x minus 8 by 5x minus 8 is equal to x squared by x plus 8. 5x minus 8 by 5x minus 8 is square the first, 25x squared twice the first by the second is minus 80x squared last is 64. X cubed plus 8x squared. Come up here, bring everything to one side. X cubed plus 8x squared plus 25 minus 25x squared plus 80x minus 64 is equal to x to be cubed minus 17x squared plus 80x minus 64 is equal to 0. There you go. there is 10x. Right. If the function of x is equal to x cubed minus 17x squared plus 80x minus 64, show that the function of 1 is equal to 0 and find another value for x, for which the function of x is equal to 0. Anyone know what we're going to do here? First pivot is wherever there's an x, we're going to sub in a 1. We would have tackled this in algebra. Long division. Long division. What long division are we going to do? Because we're going to show that the function of 1, we're going to show that x is equal to 1, isn't it? So it'll be x minus 1 then, long division is that. So first things first, check and show them. You get 5 marks there for just showing them that the function 1 is equal to 0, i.e. everywhere you have an x, put in a 1. Also, I checked that one that I kept getting wrong last week, and I got another teacher to check it, and he also getting that, so he knew that there was a problem. It wasn't me, so he didn't really very much. Right, just while you're finishing off that, everyone to know a quick little cheat as well for checking that. Anyone has this calculator, function mode, go to 3 for table, put in your function, which is alpha x to be cubed minus 17 alpha x to be squared plus 80 alpha x minus 64. Started at minus 10, ended at 10. I put the step on 1, and it will literally show you all the answers. So I'll show you anyone that comes up with a 0, you know to work out. So i.e., we know that A gives us 0. So we know x will be equal to 8. The cheat of that. Which is handy. Also, when we start moving into probability and statistics, I literally won't be able to help anyone with that calculator. All the formulas I know are on this. I don't know how to use that one with regards how to use it, and second of all, it doesn't have all the functions that the Casio calculator has. But don't forget, I do remind you, do not bring just one calculator into your Leaving Cert. You're looking for trouble. Have to bring 2 calculators into your pre's, have to bring 2 calculators into your Leaving Cert. I'd recommend 2 separate types of calculators. Right, let's look at it. So, we show that the function of 1 is equal to 1 to be cubed minus 17 times 1 to be squared plus 80 times 1 minus 64, and I take it 0 is equal to 0. Then we do long division, x minus 1 divided into x to be cubed minus 17x squared plus 80x minus 64. X into x cubed is x squared by x cubed, x squared by minus 1 is minus x squared, minus plus. That's minus 16x squared plus 80x. X into minus 16x squared is minus 16x, minus 16x squared plus 16x minus, they cancel. 80x minus 16x is 64x minus 64, which is x into 64 goes plus 64 times 64x minus 64. Change the sign of our bottom line, minus and plus, gone. Out to the side you have x squared minus 16x plus 64, x and x minus 8, x equal to 8, x equal to 8. Right, a bit of revision on this while we're here at it. I asked you to draw that graph, how we do it. Back to our functions that we did after algebra. How would I go about drawing that graph? So, cuts the x-axis at 1 and 8. How many turns in it? 2 turns. How do you know it is 2 turns? It's x cubed. It's x cubed. You should have 3 places where it cuts the x-axis. Why is it only 2? Sorry? It only touches off the 8. How do we know it only touches off the 8? 2 roots are the same. So it's a, for all the world, it's a u. And like that. Alright, so that was just a rough sketch. How will I know where it cuts the y-axis? Last number. Minus 64 will tell you where it cuts the x-axis. X-axis. So for all the world, it should be the other way around. Like, up, turn, touch, and like that. Is that alright? And this, we know this point down here, minus 64. It is important, they have been asked you to draw a rough sketch of that before. Last number tells you where it cuts the y-axis, which is minus 64. We know 1 is a root, so it goes through it at 1. And we know it has another turn in it, so it cuts. We know it touches 8. Right. In the case of one of the values from x, from part B, in part A, will generate a geometric series with a finite sum to infinity. Find the value of x and hence find the sum to infinity. So, we have an 8 and we have a 1. It tells us that in the case of one of the values of x from part B, the terms in part A will generate a geometric series with a finite sum to infinity. How will we check if the values are going to give me a geometric series? Check if it's a geometric series. Yeah, so what was my T1? What was my T2? And what was my T3? Right. When it's 1, give me the values of all these 3. What do we get? We got 1. 5x minus 8 gives me minus 3, and x plus 8 gives me 9. Right. Will that create a geometric series? I don't know. Can I check it? If you want to check if something's geometric, what do we got to do? We've got to show T2 over T1 is equal to T3 over T2. Minus 3 over 1 is it equal to T3, which is 9 over minus 3. Is minus 3 equal to minus 3? So we know that works. Just for argument's sake, check T8. So get me what, if x was 8, get me what T1, T2, and T3 would be. Just for argument's sake. What's T1? 64. T2? 40 minus 8 is 32. And T3? 16. Does this work? So, T2 is 32 divided by 16 equal to T3, which is 16 over T2, which is T2 over T1, sorry, is equal to T3, 16 over 32, 32 over 64, equal to T3, which is 16 over half. In the case of one of the values of x. So we made a mistake someplace, guys. Because it tells us only one of them will work. We know that function of 1, so x is equal to 1. 1 to be squared is 1, 5 times 1 minus 8 is minus 3, 1 plus 8 is 9. One of these shouldn't work. T2 is minus 3, T1 is 1, T3 is 9, T2 is minus 3. One of these should not be working. Find the value of x, which is 0. One value is 8. One value is 1. In case of one of the values from x from part B in terms of part A will generate a geometric series with a finite sum to infinity. Find this value for x and hence find the sum to infinity. 2 seconds. I'll see. They're both working. It says only one, but they're both working. Right. We'll generate a geometric series with a finite sum to infinity. Find this value of x and hence find the sum to infinity. What's my sum to infinity formula? Sum to infinity is equal to a over 1 minus r. So if we're using, for example, 1, what is my a, what is my r? A is x squared, which is 1 over 1 minus, what's my common ratio? 1 minus 3 minus minus 3 is? Which is 1 over 4. If it's sum to infinity of 8, what's the sum to infinity when it's 8? 64 over 1 minus what's the common ratio? A half. 64 divided by 1 over minus a half. 128. Right. Uh, 2018 paper 1 question 2. Right, 2018 paper 1 question 5. The Cephas of Dam is an infinite table of arithmetic sequences. The terms in the first 4 rows and the first 4 columns of the table are shown below. Find the difference between the sum of the first 45 terms in the first 2 rows. What are we going to do? Sorry? Fill out the table first. No need. So, the Cephas Dam is an infinite table of arithmetic sequences. Right, first things first, make a little note. Are we adding or are we multiplying? What are we doing? Adding. We are adding. Right, we are adding. Terms in the first 4 rows and the first 4 columns of the table are shown. Right, do we know the difference between a column and a row now, first of all? Sorry? Yeah. But how many? 45. Very, very important. This is a column, this is a column, that's a row, that's a row. Just make sure you know which way we're going in it, first of all. Common mistake made. Right, off you go. Get me the sum of the first 45 terms in row 1, and then the sum of the first 45 terms in row 2. Arithmetic sequence formula for, we'll find it in our logbook, in our log tables. There should be one there in front of you someplace. Try the bottom someplace. Right, what is my formula for Sn when it's arithmetic? It's n over 2 times 2a plus n minus 1 times d. Is that right? I've no like that was done. So the sum to 45 in the first row. Right, first row. What is the first term? A is 4 and D is 3. In the second row, the first term is 7 and D is 5. So sum to 45 in the first one is 45 over 2 times 2 times A, which is 4, plus 45 minus 1 times D. What do we get for final answer? Sorry? 3,150? I'm incredibly deaf. Apologies. Sum to 45 in the second one is 45 over 2 times A, which is 2 times 7, plus 45 minus 1 times, sorry, D over here should have been 3, times 5, and that is equal to 5,265. Are we happy with those two figures? Both checked. Right, so what's the difference between the two? 2,115 is the difference. Right, second part of that question. Find the number which is in the 60th row and the 70th column of the table. How are we going to figure out which number is in the 60th row and the 70th column of the table? So if you go down the first column and get T, 60, right? Go down here and get term 70 in a second. No, that's not going to work. So you're going to get the term here for term 60, and you're going to get T60 in here, right? That the order. Get D. How is that going to help me? So we're going to get a term here. We're going to get a 60th term here. We're going to get a 60th term in here. Get T70 going across. Because that will be in the 60th row and the 70th column. There's your 60th row. And if you get the 70th term along this row, that'll be the 70th column. Does that make sense? Right, off you go. Give me the 60th term here, get me the 60th term here, and then get me T70. Use that information. So you want to use your formula for arithmetic sequence input times D for this one now, and then the same for this one now. And we're going to T60 here, T60 here. What's our formula for arithmetic? It's A plus n minus 1 times D. So get the 60th term here, get the 60th term here, and then we're going to get the 70th term going across. Let's jump to the jacks really quick. Right, find the number which is in the 60th row and the 70th column. So, get T60 in the first one. First column, so 4, 7, 10, 13. A is equal to 4 and the D is 3. So that's A plus n minus 1 times D, which is 4 plus 60 minus 1 times 3. Do we get a final answer now? 4 plus 59. 2 seconds. Calculator's having a mare. So you got 100 181. And T60 in the next one is A was 7 and D was 5, which is 7 plus 60 minus 1 times 5, and we get 302. So we're here, and the first one is 181. Second one is 302. So we got our first term and we got our second term, and we want to go all the way out here to our 70th column. So A is equal to 181. What's the difference between 302 and 181? 121. So T70 then is A is 181 plus 70 minus 1 times 121. 8,530 is what we're getting. And that is the 70th term in the 60th row. 8,530. Right, the next bit of the question. The first two terms of a sequence are A1 is equal to 4, A2 is equal to 2, and the general term is defined by AN is equal to AN minus 1 minus AN minus 2, where n must be a number greater than 3. Write out the next 6 terms of the sequence and hence find the value of A 2019. Anyone know what this looks like? What are we thinking of? We're in on the Lord, let's ask him. Anyone think this looks familiar somehow? It should. 7 days since we last did one. Fake goes flicking back. What are we finding instead? They've literally just replaced a certain letter with A. I mean, U. And then we're doing your UN plus 1 and your UN plus 2, and then put them all into the sequence that we spent going for 40 minutes, I say 40 minutes doing last week. The only difference is instead of using the letter U, we could just use the letter A. So if I was to write out the next 6 terms of the sequence and hence find the value, if we have A1, A2, what am I going to do here? A3. I'm going to go to A3. A4, A5, A6, A7, A8. Get the next 6 terms. What am I going to do? How am I going to figure out what goes in here? If it's A3, for example, that's going to be A3 minus 1, A3 minus 2. If it's A4, it's A4 minus 1, A4 minus 2, and so on. This is our sequences that we were doing last week. Let's use A instead of U. Off we go. We're using 3 first of all, and then we're going to use 4. Here on the slides, guys. Right, let's have a little go at it. So, we know what A1 is, we know what A2 is. Let's look at A3. A3 will be A times 3 minus 1 minus A times 3 minus 2. So that will be A2 minus A1. A2 we know is 2. Minus A1 is minus 4. You get a value of minus 2. A4 then. A4 is A times 4 minus 1 minus A times 4 minus 2, which is A3 minus A2. A3 is minus 2 minus A2, which was minus 2, is minus 4. We can kind of spot a pattern now, can't we? For example, A5 is going to be A4 minus A3, and A6 is going to be A5 minus. So, A5 then, we can spot the pattern, is going to be A4 minus A3. A4 we figured out was minus 4, minus A3 is minus minus 2, minus 4 plus 2 is minus 2. A6 is A5 minus A4, A5 is minus 2, minus A4 is minus minus 4, which is plus 2. A7 is A6 minus A5, A6 is 2, minus minus 2 is 4, and A8 is A7 minus A6, A7 is 4, A6 is minus 2, we get 2. Create your sequence. A1 was 4, A2 was 2, A3 was minus 2, A4 was minus 4, A5 was minus 2, 2, 4, and 2. Right. Write out the next 6 terms of the sequence and hence find the value of A 2019. What are we all doing, boys and girls? Sorry? Is it geometric? What is your geometric then? How can we check if it's geometric? T over T1. So we'll check is it geometric. 2 over T2 over T1 is equal to T3, which is minus 2 over T2. 2 over 4 is a half, is equal to minus 1. Not geometric. Right. What are we going to do so it's not geometric? How are we going to get up to the value of A 2019? And this is this second bit is actually a junior stuff. It's a bit of logic to it. It's not as hard as you think it is. Anyone, any idea? If I know, has anyone spotted that? No, first thing, let's see, can we spot that? Pattern is repeated, right, come on. When is the pattern repeated, Adam? So it's repeated after the sixth term, i.e. T1 is equal to T7 and T2 is equal to T8, T3 would be equal to T9 and so on. How is that going to help me? See if we can use a bit of logic on it. Gav, any idea down there? Staying very quiet below in the corner. Man, 2019 divided by 6, what do we get? 336.5, right? That's not really going to help me now, but it does tell me something. What's it tell me, Gav? Sorry? 2019. Yeah, we're along the right line. We're halfway between the 336th and the 337 pattern. So halfway, for example, you went to 2016 divided by 6. What's 2016 divided by 6? 3, 6. So what do I know about 2016? What do I know about the 2016 term in the sequence? 2016 term in the sequence is 2. Because it's gone 336 full revolutions through your sequence. I know the 2016 term in my sequence is 2, i.e. goes in exactly, 6 goes in, it repeats every 6, you finish out your 6th on 2, so I know 336 one is, sorry, the 216 one is 2, 2017, 2018, 2019, sorry, 4, 2, minus 2, sorry. So if you forget about these last two, this is the 6th, it's 4, 2, and then 2019 is minus 2. Just a bit of logic. 219 term is minus 2. Because this is your 2016, forget about those two for a second. 2017, 2018, 2019. All they want you to see there with the 7 and 8 is that it's repeating. Just want you to get this part is repeating. Right. Another one of these. Nearly there, guys. 35 minutes. So do probably one more of these, like you know, algebra revision question, no trigonometry revision question. Let's get very repetitive. I want to leave a few more to come back to that when we're doing our paper revision in the last 6 weeks. So, diagram below shows the first 4 steps of an infinite pattern which creates this that word triangle, so Pinsky, I would say. The sequence begins with a black equilateral triangle. Each step is formed by removing an equilateral triangle from the center of each black triangle in the previous step as shown. Each equilateral triangle that is removed is formed by joining the midpoints of the sides of a black triangle from the previous step. So the table below shows the number of black triangles at each of the first 4 steps and the fraction of the original triangle remaining in each step. Complete the table. Hard thing about that is reading that and figure out what the translation is. But that is what the question said, question 8, question 9 is all about. The first 6 questions you'll read, you should have a fair grasp of what they're asking you. The last 3 questions is where they catch you on the English. It's the practical application of what you know. So, this is a lot easier to fill out than you think. How many number of black triangles in step 0? 1. How many is in the first step? 3, and so on. Off you go. See if you can fill out this best you can. Right. So, number of black triangles in step 1, 3. Number of black triangles in step 2, 9. And number of black triangles in step 3, 27. So we can clearly see all we're doing on top is multiplying it by 3. Right. Fraction of the original triangle remaining. So it's a full triangle here. How much of this is black? 3/4. How do I know it's 3/4? Because they're equilateral triangles. If you take out one equilateral triangle, you're left with 3/4. It tells me this one is 9/16. Anyone, any idea what this is down here then? 27/64. Why 27/64? Each time it's reduced by 3/4, isn't it? Right. Part B. Write an expression in terms of n for the number of black triangles in step n of the pattern. Off we go. What do you reckon? 3n or 3 to the power of n? 3 to the power of n. Alright, 3 to the power of n. Very important. How do I know that? 3 to the power of 0 is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. Step K is the first step of the pattern in which the number of black triangles exceeds 1,000 million for the first time. Find the value of K. Right, to understand the bottom bit, what does n represent here? Number of? N represents? Number of steps, very important. N represents the number of steps. The answer you get represents the number of black triangles. N represents the number of steps. Right. Step K is the first step in the pattern in which a number of black triangles exceeds 1,000 million. Logs, good man. Set it up for me. Three to the power of n is equal to one small mistake. And it's a common mistake that I'd say nearly half to 3/4 people made that year. They try to stop people from making a mistake by blacking out one of the words. Inequality, yeah. Don't use equals. If it says exceeds, use greater. And that is going to make a massive difference in a minute, because it came up in 2018, and it came up in 2019, and it came up in 2017. Right. Off you go, lads, logs. I'm sure we all remember our algebra work from the beginning of the year. That's the first thing you should be doing if we're working with logs. Not that I keep telling you, when we're doing logs, what should you have open in front of you? The log page. When you see logs, log page open in front of us. Okay, what are we thinking? I think I see it right now. Top right corner, get out of the jail free card. And 99 times out of 100, you'll be right. And I'm going to explain to you, this is the only time you can't do it, and it comes back to the whole thing of exceeds. When you see exceeds, it's inequality. When you see equality, everyone goes to top. Follow through with me. Same. So, why can't I simply say if a to the power of x is a y, why am I not going to go the log of 1 multiplied by 10 to the power 9 to the base 3 equal to n? As it said, inequality. You want to make it even a little note next to your rule there. Cannot use this when we have inequality. Right, that tremendous statement now. You have to understand why. Explain to me the logic of things there. It's not equal to the power. Yeah, I know what you mean. But why? Why can't we do it very much? You understand? Because they like to bring this little thing up every year and catch people for 5 marks. Like you would have whacked through that, this came up for 10 marks, you would have got, I think 7 out of 10 you would have got that year. If you did use equal to the work or whatever, you would have dropped 3 marks at the end. It would have affected your question. The junior search logic on inequalities, what affects them these? Sign change, man. What is the problem with sign change with inequalities? If it's negative, negative change in sign. Alright? That's why we can't use this rule when we're bringing things over and bringing things back. When it's an inequality sign, we don't know whether it's positive or negative. I.e., we don't know if n is positive or negative. That's negative, that flips that. It's positive, it stays the way it is. We don't know what n is, we can't just bring it over and back. So, anyone know the other way, the rule, anyone know the other way when you don't use that rule? Some teachers actually teach it this way to avoid people using that rule. I think that rule is the handiest thing to do because it involves, you just basically read the rule straight out of the logbook. But some teachers completely disregard that rule and use a certain way. No, not ln. Anyone remember maybe your teacher taught you this way? I want to get him down. So I'm going to introduce. By the way, in this term, we don't know what number it is, so it's k more than n because it's step k. If you want to get him out of there and k is on its own, you introduce the base the same as the number. Because any number to the same base will leave you with 1. So you introduce log to base 3. So even if you want to make even a little note in your logbooks, instead of using this rule, with inequalities, introduce to the base same as the power, same as the indice. And what I mean by that is, i.e., 4 to the base n, say log of 4 to the base 4 to the power n. So, i.e., 4 to the power of n, log of 4 to the base 4, log of 4n to the base 4. So, we can say now that the log of 3 to the power k, the base 3 is the same as the log of 1 multiplied by 10 to the power 9 to the base 3. Did you do it a different way? All right. Right. So, rules of logs. Looking at our logbook. We want to get the power up out of the sky. How am I going to get him down? I can just bring him to the. Yeah, as I said, I don't have the logbook in front of me. I think it's a rule 4 or it's one of the rules that rule 3 or 4. Rule number 3. Rule number 3. So you can use rule number 3. We have k times the log of 3 to the base 3 is greater than the log of 1 multiplied by 10 to the power 9 to the base 3. Log of 3 to the base 3, 1. So k is greater than the log of 1 multiplied by 10 to the power 9 to the base 3. K is greater than what are we getting? We're getting 18 log to the base 3 of 1 multiplied by 10 to the power of 9. Again, 18k is greater than 18.86. The question asks us the first step of the path in which a number of black triangles exceeds 1,000 million. Step number 19. K is going to be equal to 19. So, the important thing today from that is when it's inequality sign, we can't use our Taylor-J rule for logs. We must introduce the base, which is the same as the indice, i.e. 4 to the power of n, we introduce log to the base 4. If it was 25 to the power of n, we introduce log to the base 20. But we introduce the same base of the power of n. That understood? Very, very important. They plucked that one in there the last 3 years in a row. Right, part C. As I say, we'll finish with this question and we'll jump into something else for the last 15 minutes. So, 20 minutes left. Step H is the first step of the path in which the fraction of the original triangle remaining is less than 1 to 100 of the original triangle. Find H. Right, what are we going to do here? So up here we were dealing with the number of black triangles. Down here we're dealing with fraction of the original triangle. So we're dealing with the, instead of dealing with the step and this one, we're dealing with the step and the bottom. We're going to be dealing with step and bottom. So we were dealing with the number of black triangles the last time. We were dealing with 3 to the power of n. Step H, the first step of the pattern, which the fraction of the original triangle is remaining is less than 1 over 100 of the original triangle. Find the value of H. Go on, find fraction of the original triangle in. Less than 1 over 100. It's the exact same question. They asked you twice in a row. So the first time they were looking for you to use this one. Next time they were looking for you to use. Right, let's see what we learned the last time, which we were paying attention on to go in the second question in a row. Hopefully you're all paying attention. I must once again. What's our expression for the second bit, Gav? That low? 3 over 4 to the power of n. 3 over 4. The first one was 3 to the power of n because we're multiplying by 3. What are we multiplying at the bottom? 3 over 4. So 3 over 4 to the power of n is less than 1 over 100. By the way, in the last one, k was greater than 18, but it was k is equal to 19. It's equal to 19. Yeah, actually, Dr. Mark, you put it equals to instead of the sign. Right, we have a little go at it. So, 3 over 4 to the power of h is less than 1 over 100. As I said, we can't use our rule because we have an inequality sign, so we must say the log of 3 over 4 to the power of h, the base of 3 over 4, less than 1 over the log of 1 over 100 to the base 3 over 4. H comes down to the front, log of 3 over 4 to the base 3 over 4 goes to 1, is less than the log of 1 over 100 to the base 3 over 4. H is less than I'll just check it. Right, someone explain to me why I'm only after getting 7 out of 10. Nope, you're still going to get 7 out of 10, not equal to. Equal to, they only drop you a mark. It's called like 9 star. You only drop 1 mark. Anyone able to tell me why I'm after dropping 3 marks? Once again, junior cert knowledge of inequalities. Sorry? No, log to the base 3 over 4 is negative. What happens to negative? Inequality with negative, bring it over. Or divide by negative. Must flip the sign. Must flip the sign. He is negative. I.e. must, where 16, h is equal 16. Or sorry, first time it happened, h is equal to 17. 16.0784. H is equal to 17. All right. Make sure you're always checking, because log to the base 04 will give you a negative figure. It's fraction. Right. What fraction of the original triangle remains after an infinite number of steps of the pattern? What's the important word there? Infinite. Oops. Formula for infinite, for dealing with what type of sequence is it? Geometric. Formula for infinite sum to infinity is a over 1 minus r. One over 1 minus. What's going to be equal to? What's the problem? That don't make logical sense. Must make logical sense. What fraction of the original triangle remains after a number of steps? Fraction of the original triangle, we start with 1. Is it decreasing or increasing? Always double check your answer, make sure it makes sense. Decreasing. Very, very nasty question. Make you think to use a sum to infinity. It's literally a logic question again. Once again, it was a rotten one. What fraction of the original triangle remains after an infinite number of steps? We can say that the fraction is going to reduce to 0. Fraction is going to reduce to 0. As you go along, it's getting smaller and smaller and smaller and smaller and smaller. We can say the fraction is going to reduce to 0 as the triangle increases in steps. Just be careful, always double check your answer, make sure it makes logical sense to what the question is asking. As the number of steps goes up, the fraction of the triangle goes down. Right, so, just so we know where we stand, ye are going to be quite strong on paper 1, i.e. paper 1 is algebra, differentiation, integration, sequence and series, and what we're doing next week, which is financial maths. We literally have only done trigonometry from paper 2. Alright, so we're doing coordinate geometry after next week, but you are going to be sitting your mocks with really only a small bit of coordinate geometry of the line done and trigonometry for paper 2 with me. You need to go back over and start looking at probability and statistics. That's the next block after the mocks. We'll say that's the February to Easter block here. But literally paper 2 is trig, probability and statistics. So you won't have, from me, my point of view, and with me, you won't have any probability and statistics looked at before you go into your mocks. Is that right? So just be ready that some of the questions, you're going to be looking at some of the questions going, Jesus, what the hell is going on? So make sure if you are doing your own revision, that's what you should be focused on, probability and statistics. Is that fair enough? Before I go over some of the questions with you. Right, for the last 10 minutes, let us do a bit of algebra revision. What am I going to do? What am I going to do? Not going to do that. No. Right, off we go. Exam craft 2019, paper 1, question 3. Last 10 minutes. Have a whack off this. Sorry? Yeah, exam craft 3. You're going to be doing the DE. I think you do. You do the double one. Yes, the DE. doing the same now. Next week we'll be doing probably money for the first hour, and next half an hour we're doing trigonometry revision and differentiation revision. One more minute. Right, guys, let's look at it. So, square both sides. Square the first, x squared, twice the first by the second, 4x squared the last, 4 is equal to square the first, x squared, twice the first by the second, square the last, 69. Right, knock them off. X squared and x squared. 4x plus 26x is equal to 169 minus 4. 30x is equal to 165. Divide both sides by 30. X is equal to 11 over 2. X is equal to 11 over 2. Right. Hence solve 3y plus 2 is equal to 3y minus 13. Important word. Hence, good stuff. Gav, why is hence important? You use the answer from above, man. Whenever you see hence, answer from above. How is that going to help me? 3 to the power y, yes, 3 to the power y. What can I say? I'm terribly deaf. It's ridiculous. It's more than embarrassing. Alright. It's more than embarrassing. I'm not here. You could. Easier way to do it. Look at the top, look at the bottom. What's the similarity between this and this? Sorry? Yeah, 3y is equal to 3 to the power y is equal to x. All they've done is subbed in a 3 to the power y instead of an x. And all they've done down here is the exact same thing. 3 to the power y is equal to x. It's literally the same thing. Right. So 3 to the power y is equal to 11 over 2. Abby, what am I going to do? Power stuck up in the sky. What am I going to do with it? Man, how much have we paying attention to me the last hour? We've done this twice already today. What rule are we going to use, guys? Help her out. We're going to use our log rule. Top right corner, let's go. Log rule. When we've our power stuck up in the sky like that, we use our log rule. So that is the log of 11 over 2 to the base 3 is equal to y. 1.5517 is equal to y. 1.55 equals y. Right, boys and girls, that's a wrap. We need to go back and start looking at some of the videos and some of the revision things. All right, we need to start going back doing them. And I will see